Oh, you almost need this just behind us. Okay, 3, 2, 1, smile. Lovely.
Cool.
All right, so welcome everyone to the session on what is a data scientist. We've expanded the topic a little bit to go in deeper into some of the things that data scientists do as well, because we think that's important for defining what a data scientist is. So we're going to start with introductions. I'll start with myself. So I am Seth Dobrin. I'm the Vice President and Chief Data Officer for IBM. I've been with IBM about 2 years. Before that, I was in industry and in our clients' businesses running similar programs. And I'll go a little bit into my background because I think that's important as well. My background is actually in molecular and statistical genetics. And I got my PhD about 20 years ago, leveraging a lot of the tools that we leverage today in this space. And so we'll go next to my colleague here.
Hi, my name is Jorge. I'm originally from Spain, as you can notice by my accent. Yeah, actually, I'm working as analytics director in a company called ADS Securities. That is the focus is in trading, also investment banking and wealth management. But I'm working in this space for more than 23 years. I was very lucky because I started my career as a statistician, and I work in different geographies: Spain, UK, Australia, and also here in the Middle East. And I'm very happy. I'm passionate about my job and about statistics, data, technology. So and that's me.
Hello, I'm Eva Marie Müller-Stühler. I also work for IBM. Same, I can only agree. I think I have the coolest job in the world because I'm not just the data scientist for IBM or the chief data scientist of IBM. I'm also in the best region, which is EMEA, basically Turkey to South Africa. Before that, I was chief data scientist for KPMG in London. And my background is I studied mathematics. I did my PhD somewhere between mathematics and medical physics a long time ago.
Hi, good morning. I'm Jose Pablo Redondo. I work here on DO. I'm the head of data science team on DO. Here working together with Smart UI, trying to make the data together and making sure that it's available to the world in the right way. My background is a little bit of, I'm a statistician, at the same time a computer science. Work a little bit both on both areas, both as a data scientist and as a solution architect. So I kind of have the big data background into this topic of conversation.
Hi, I'm Tom Smith from the UK's Office for National Statistics. I'm a physicist. I might not be a data scientist, but I think probably for about 20 years, I've been interested in what you can do with data that's held by government and public sector agencies, and what you can do with that data for public good, for social impact. And so really data science for me, and for my interest, is very much focused around public good, social good. So in terms of my technical background, I trained as a physicist. I then did a PhD and master's in knowledge-based systems and AI back in the 90s. At the time, there was very little opportunity to bring that work into government. What I see now, and over the last 10 years or so, is a collision of the worlds of public sector, of businesses, and the worlds of technology and data transformation and data use. And that, for me, is why data science is the most exciting area to work at the moment, and why data science in government particularly, I think, is the most exciting, challenging, and potentially high impact for social good area you can work. So that's why I'm excited about the session today and the whole conference. I think we've seen some inspiring examples of work going on.
All right, excellent. So why don't we get into our first question, and I'd like you all to explain a little bit about how you got where you are today, how you got into data science, and maybe your journey especially Jose, since you've been a data scientist. And also maybe, Jorge, especially since you and I come from a stats background, maybe you can explain the difference between what stats is and what data science is or machine learning is. There's been a lot of talk at the conference about statistics, and I think there's a lot of value you can add by going into the journey to predictive and prescriptive analytics. So, Jorge?
Yeah, so I think it's a very good question, no? That, and I think that how we are here, I think it's because actually we are in a really disrupted world, no? And what has been done to this, what is the key important thing is our digital world, no? So actually, everything that we do is saved in digital. So the data is saved in digital. So if we speak, our conversation is saved in data. It's translated into the data. Our image are data. So everything is data, no? And now there is one thing. The other thing is the technology. So 20 years ago, the technology, we didn't have the technology that we have now, no? And the other thing is there are the requirements to go very quickly into the market, no? So then these three components, technology and obviously how mathematics and how the algorithms has run during this period, no? When I started, I used to do simple statistics, and then I analyzed what happened and why it happened. But now we are more in the world to predictive, what is going to happen, no? And then this is where the world has evolution in terms of algorithms, in terms of to build predictive modeling, and this is how everything has changed. So we are here. We started with one technology, with a small data, yeah, with a lot of issues in terms of manage this data, and now we have the capabilities in the organization, also in the technology, that we can do more and we can do faster, and especially we have tremendous volumes of data, no?
Yeah, so and I think that's a good point, right? When we were doing our studies in statistics, we used many of the same, in fact, most of the same algorithms we use today. It's just there's two primary things that have changed. One is the amount of data, and particularly labeled data, so data that we know what the ground truth is. And the second is the capability to constantly reanalyze the data and the models to keep them updated, hence the term machine learning, where the machine keeps retraining the model. So that's a really good point. Eva?
So, yeah, I think from my background, it's...
Maybe move the mic closer.
Sorry. From my background, I'd actually say I'd never planned to be a data scientist. I always just did what I was passionate about, and somehow it came all into pieces, and suddenly everything made sense when there was this job, data scientist, and everything I've been doing in my past, and then suddenly lent into it. I think going back to the question of like where he got here, I started coding when I was 8, and I only started coding because my dad wanted to learn how to use a computer, and I wanted to hang out with my dad. And then similar situation at school, my friends were coding, and I wanted to spend time with my friends. And but then studying mathematics, mathematics been very, very theoretical at that time. I did a research year in number theory, and when I came back and people asked me, what were you doing? And I was like, yeah, actually I was sitting there and thinking about ring sign functions, and everyone was like, what is ring sign functions? And so how the time developed, math suddenly became more and more applied. And even when I finished university, most of the mathematicians, they either went into insurance companies or into consulting. I went into the consulting bit, but I always missed the math. And so I brought the mathematics into the consulting business and brought my passion with me. And I think that's where I have been really lucky, and that's where time has changed, because we are now actually using math and using a logical approach to business questions and moving away from the gut feeling and into like, okay, let's calculate it through. Let's see how we can actually make it tangible and see if it's actually the way we think about it.
Yeah, and that kind of hits on an important point too, right? You know, if you think about what data science is, it's really about applying the scientific method and math to business problems, right? That's really what we think about it as data science. To completely oversimplify it, in terms, I think, that the general population can understand. Yeah. Jose?
Yeah. One of the things is when we think about how do we came here, as I think about a little bit of when I was studying statistics back in 2000. It was a time in which people work and rely on samples. Everything was done on sampling data. You sample 1,000 people, and then you estimate the amount of something about a million people. So the problem is, during that time, statistics was not so into the market because people didn't rely the results. You didn't rely the results of any survey that you do for voting or politicians. They didn't rely on any kind of statisticians. Now, what happened is after the big data came in, and after we started collecting so big amount of information, it was no longer about sampling. We could even rely somehow on having almost the entire population. So it comes to the point in which people believe that we do have now all the knowledge. We can generate a real insight of what is happening something around. That's why right now everybody is talking about data, because there are cases, there have been cases around the last 4 or 5 years in which there have been clear success of getting insight out of the data because they had so much amount of data. We're talking about Google, Facebook. They make so much money about basically identifying someone just by looking at their data. That is the new way to go. Now, in regards to the question of what is the difference between a statistician and a data scientist, to me, I would never say that there is a clear difference because it's classifying two things that are different. I mean, a data scientist has to use statistics to do his job. I mean, trying to do data science without statistics doesn't make any sense because the main, and we'll talk about maybe a little bit later, I mean, what is the process of data science? The first 3 steps is basically statistics. So doing statistics alone, it might seem a little bit moot. It's incomplete. And it's not entirely right that a statistician only knows how to do descriptives. We do have a lot of capability of doing prescriptive predictions. We can calculate trends. There is a lot of algorithms in order to do that. Yes, we may not study machine learning, which is the new wave, but there is a difference a different approach when you use machine learning statistics. Statistics will not only give you the result, but it will only give you the why. It will give you a closer answer to why this is happening. Machine learning usually tends to be a black box in which you put the data in, it'll spill your result, it will be accurate, but you will never understand why it happened.
Yeah, and I think you hit on a good point as well, right? Where once you have the data and kind of the features developed, so the elements that you're going to focus on, one of the first things you do actually between those 2 steps is use statistics to get a description of your data, right? So you need statistics as part of this process to understand your data before you can even get into the predictive components. And there's sometimes where that is good enough for the answer, right? I'm a huge fan of Occam's razor, right? Keep it, the simplest answer is always the right one. And so your point about the relationship and not the difference is critical. Tom?
One way of thinking about data science and data scientists is that we test hypotheses to generate value from data. And I'm going to unpack that a bit. I think there are 3 areas there that are really exciting. The first is data, and obviously the title of the conference kind of gives it away that there's a lot of interest here. And I think what's shifted over the last few years is our understanding of what data is useful. So if you come from a classical national statistics background, you often think in terms of surveys, and many teams still do, and surveys are important. You might also think about registers, administrative data, things that you have in your systems, and there's huge value in that source of data. You might be thinking around tax records or benefits or crime data and so on, and there's lots of value there, and groups are rightly trying to squeeze every ounce of value out of that. But the third bit of data at the moment that we're seeing is sources that really 20, 30 years ago, the majority, the mainstream of statisticians really would not have considered to be in their remit. Things like Earth observation data. We've had some fantastic examples around using satellite imagery for producing statistics on water, food security, forestry, deforestation, and so on. Those sorts of sources, they're new, they require different tools. Which brings me on to, I think, the second area. So data's the first. The second is generating and hypotheses. You need the tools to work with the data and the materials you have at hand. And like all craftsmen, data scientists need to understand the tools in their toolbox. And that really is where people are coming from technical perspective, that mathematics, that understanding of deep learning, machine learning, and so on is really important. And that's absolutely spot on. But I don't want to overplay that bit. Because the third aspect, and to me this is the most important aspect of what data science is and what data scientists do, is around value. And value is what the end point is. We don't care about a data set or a research report or a statistic. What we really care about is influencing decisions that are made in the real world, whether they're from businesses, whether they're from governments, whether they're from global communities. Data, statistics, and research and data science are all a means to fuel that and to underpin decision-making and to make change happen. And for me, the important thing around data scientists is that you get embedded in those questions. So rather than producing an output or a model which sits on a shelf, you are intimately involved in the decisions and the discussions that are going on. And you know what analysis you're looking, what analysis can I provide that can support or underpin this discussion and understand at what point in that discussion should I be providing that information. That's the key bit around value. And I think that, for me, is the big distinction between data scientists and other parts of the analysis and statistical systems.
Yeah, and that's a really good point, and that kind of segues nicely into how I got here. So like I said, my background is actually in genetics, and I worked in a life sciences company, and really leveraging data and machine learning to drive new business models and to drive new value for the company I was at before was critically important to the success of the company, and even doing the same thing at IBM where I am, and helping our clients do it. And I think it's really, really important to tackle these projects not as a big ocean, but tackle them based on specific use cases or decisions that you're trying to make that are tied to a specific value. In business, it's really how do you make people's life better, cheaper, or faster. In government, it's the same thing, right? It's about better, cheaper, faster for your workers, the people you're trying to help, or your citizens. And I think that really drove my journey from being a hardcore scientist into this aspect of business, of leveraging data, statistics, machine learning, and even what we think of as AI to drive new business processes. So I want to change gears just a little bit here, and I'm going to start with Jose, because you talk about what a data scientist is, and from your profile, you actually have the spectrum, you have experience in the spectrum of skills we expect from a data scientist. So why don't you describe, number one, what you think data science is, what skills you need, and is it a team or is it a person, and how do you approach that at DO in your case?
It's true. So the thing is, the industry has evolved to a point in which what they describe as data scientists is literally a unicorn. I mean, yes, I do have the background for basically covering all what's required for a data scientist, but what it means is I'm not very good at either of them. I can be a very good manager, but I'm not, and especially because you need people specialized on the different areas. So it is clear that from what is required in order to add value to the data, you need certain things. You basically need a statistician or a mathematician, someone with experience, someone who's not afraid of looking at numbers. Because one thing that I've seen on multiple teams around the world, they come and see, oh, I've developed a new super vector machine who's going to develop is going to give me the accuracy, I don't know, how to position your Pizza Huts more properly. And then it comes to the question is, what's your accuracy? How you can verify mathematically that you have done the right calculations. They can't do that because they lack the mathematician background to prove their numbers. So having a mathematician is critical. And that mathematician, does it really require to know Java? Does it really require to know R? Maybe R, it's okay. But as long as he knows how to tackle with data, with numbers and data, that's okay. But this guy is not the one who's going to put your solution in production. You also need a data engineer, someone who understands a little bit of the mathematics kind, so he can understand what the jabble, the mathematician will say, and can translate it into a code. You need a visualization, a web developer, mobile developer, someone who's going to make it readable to the world. And that's it. That's your team. It's important to have at least one of these three guys to be the idea guy, the guy who has that point of, hey, we can do this way. But as long as one of them is like this, I think in my team, I always have these three configurations. I have one guy with is a master in business intelligence. He can develop dashboards like crazy and make it available for everybody. I have a mathematician who can understand the numbers and correct everything that we do. And we have a data engineer who basically puts everything in production.
Good, excellent. And Tom, how about you? And maybe you can chime in a little bit also on this is kind of a techie, sciencey field, and people may not think diversity is important in this field. Maybe you could talk about how diversity adds value to your team as well.
Absolutely. And I think the distinguished panel are going to talk a lot about the technical aspects, and absolutely right that that's a fundamental part. But I think what's a good data scientist is very similar to most fields. How do we recruit? How do we build? How do we grow data scientists? And three of the things that I always look for. The first is curiosity. You've got to be interested in problems and interested in changing things and interested in what you can do. And that really drives other things. So if you're looking for a good data scientist and a good part of your team, then that's the first aspect. And that kind of goes for clearly every field you're talking about. But I want to put it out there that that's a fundamental component, a fundamental part of the data science toolkit and armory, if you like. The second one is around problem solving. And this came back to the kind of early discussion around value. You need to be interested in solving problems. This is a very applied field. All of the tools there are about solving problems, helping people, helping organizations. They're not about producing theorems, producing research papers, and so on. So that's your kind of, you have to have a drive for that, for public problem solving. Some of those things you can learn. You might ask, a data scientist born, or are they bred, or are they molded? I think you can learn some of that, but actually, you know the people in your teams who are curious and passionate about solving problems. It's the same in data science. And the third thing I would say is always excited by the art of the possible. So there's something about bringing together what is possible technically, but applying that to problems. And so this isn't a theoretical, mathematical interest. This has to be driven by what is possible, what's out there that we could use. And that really is, I think, around continual improvement in your teams and in your work. If you're always looking to see how you can apply new techniques, new tools, new data sources to the problems that you're facing, then I think you've got there a really good starting point. You need the technical expertise as well. It's certainly a team sport. You do not have a single data scientist that can bring together all of those attributes. People often talk about unicorns. I don't believe there are such things. I think a team of data scientists embedded or working closely with other parts of the organization and business is where the value is. And I kind of say something else as well. We've talked around data science a lot. I think the fundamentals, the infrastructure, are what many organizations and people in the room are also really focused on. If you're talking about your technical estate, the systems you have that acquire, store, manage, and make available the data that you're working with, that's the foundations to any good data science team. Data scientists often build the structures on top of that. They produce the visible outputs, but you need the foundations. And so without those foundations and really focus on that, then your data science team is really going to be spinning their wheels. And you will be spending quite a lot of money and energy in recruiting and building that team, and maybe without much value back. So you might be setting them up to fail. So don't forget the fundamental parts and the kind of digital and data transformation that many organizations are going through.
Excellent. Eva, why don't you address the same question, but maybe talk about the difference of a diversity of backgrounds as well. So why is it important to pull in people from all different backgrounds into these projects?
So I think where I learned most about data science is actually in my years in corporate restructuring, because in corporate restructuring, you're constantly on the edge of companies failing and closing down. And every step, every day you do is constantly showing an impact, changing it, and trying to keep it alive. And combining that and really saying, okay, we have this patient here. How do we make him survive? I think that's, and I love the fact what you said from the other data science perspective. I think one of the best people in my team in the past, he couldn't code at all. He was an absolutely brilliant and amazing mathematician. He was the, we called him the player coach. His job in our team was to constantly challenge a team and say, does it still make sense? On the diversity, different people look at different things from a different perspective. Women have a different language to men, mathematicians have a different language to business people, and that's why, in my opinion, like the ideal team is very, very diverse. It has an open mindset and an open respect to each other, that you, even though you sometimes go home and go like, oh my God, he always challenged me. Why can't he just take it for granted? It's actually the best thing that can happen to you, because he or she might see it differently. And I've seen so many AI solutions, especially AI solutions in the market at the moment, which are so incredibly sexist, so incredibly racist, and that just don't work because it was coded by a very specific thin layer of society and never challenged by someone else. And I think once you produce these and put them into the market, the risk for society is actually really high. And that's whereas like what diversity in the end becomes so important, to say, okay, no, we checked it with our team. We realized from all angles. I mean, the famous image recognition in Stanford, where they had people looking at taking pictures and uploading, and came up with famous art, which was one of the biggest fails and most embarrassing fails, I think, ever in AI solutions. And these kind of biases you can only tackle and reduce when you have highly diverse teams.
Yeah, and you bring up a really good point, whereas if you look at most image recognition algorithms that are pre-trained today, they work really well on white men, so on 4/5 of the people up here. They work okay on white women. As you get into African populations, they generally fail. So there's a big effort to retrain them on African backgrounds now. And even similar with consumer-facing voice devices like these home devices you have. You know, we have several at home, and I say something to it, it works great. My wife tries to say something, and it doesn't work. And that's a failure in the training of those algorithms that the industry is trying to address today.
I lower my voice every time I need to speak to Siri, otherwise she doesn't react, or it doesn't react. And I recently had an experience with a robot, and it was highly disturbing because I was standing there, and the robot lowered itself down on my level and started flirting with me on a level where I kind of thought, like, it's a business environment, it's not okay anymore. And the woman who was there with the robot was like, yeah, he is very, very flirty with women. I was like, it's an it, I'm sorry, and it's awkward. Then I started asking her the question, and it just didn't react. And I kept on repeating it, it didn't react. Suddenly and I was like, come on, tell us a joke. It completely ignored me. Then my male colleague was like, tell us a joke. And out came immediately this really upsetting joke about sexual harassment. And I'm like, and you're trying to sell this to our schools? I'm sorry, but are you sure that we want our kids to be surrounded by AI solutions that are so biased? And so that's why it's so important to have all the sides in the teams.
Great. And Jorge, maybe you could address the same question, but talk about, you know, kind of the diversity of technologies that underlie this, in addition to, you know, how they've changed over the journey that you've had.
So I would like to start showing this. So the mobile that everyone has. So this is the source of the data. So everyone here in the world, is producing data through here. So, and imagine a data scientist, is composed for two words, no? Data and science. Science, we talk about everything about mathematics and everything, and data. Imagine one data scientist cannot do everything alone. So we need too many components in our roadmap. So we need Imagine, for example, that you are running a campaign in internet, yeah, for something. Then you need to collaborate with the marketing director, with the sales director, in terms of to detect which is the case study, which is the use case, which is the benefits. Yeah? But you need to think about how you are collecting the data. You are collecting the data, yeah, from external sources, from structured and unstructured data. So you need to have in place a team that understands all the pieces, yeah, from the business benefits and also from the technology. The other day, for example, I was reading 2 books about one technology called Kudu. That is a platform, yeah, well, it's a product, yeah, that is for big data that is going to help to produce real-time analytics, so to produce business intelligence analytics. So then you need to read a lot, to be honest, yeah? So you need to participate a lot in forums because every day, yeah, every moment that is passing, the community in from Hadoop, Apache, everything, they are inventing new tools, yeah, that they are helping companies, yeah, to produce better algorithms, to manage much volume of data and everything. But at the same time, and this is something that the companies need to be, and government needs to be aware about, that is the component, the data component, that is very, very important also. And the data scientist needs to collaborate with legal, needs to collaborate also and have in mind, yeah, all the data governance in the company. So the data scientist is not only a person that thinks and knows the algorithms, yeah? So there are too many components in the company that you need to work with, and also in the public sector, in the company, that you need to work with, yeah? If you don't work with that, because you need to estimate what technology you are going to use. You need to estimate your cost. You need to speak also, for example, with providers, with consulting companies, that they are going to tell you also, they are going to help you in terms to determine which is the best technology in this moment, which is the more efficient, yeah, what is happening. And also the operating model now also have changed a lot, yeah, so.
Yeah, very good. And then, yeah, you.
I just wanted to ask you, because Tom mentioned it, and then you replayed it better. Is basically, you do a lot of work about adding value to the business. And you also said that either they take us for granted or they ignore us at all. I think it's very important to bring a point. If anyone here is from a commercial team, marketing team, technical teams, what I've seen on the past is that these teams either, they come to you like, you're a data guy, but you have no clue about commercials. You have no clue about how to sell telecommunications, or how to sell TV. You can't come to me to tell me how to do my job, because you're not an expert. That is one of the main challenges when you're trying to bring value to your own company, because they either tell you, you are not an expert, and then basically whatever you tell them, they ignore you, or they go to the opposite way, which is, I'm expecting something from you 2 weeks ago. This guy, hey, wait, this takes time. It's not tomorrow. So I was just kind of reminding, when I said about what is the perfect team to do data science, and I always forgot a 4th person, which is someone who has to come from the other department to be the speaker of the speaker of experience. I think it's also interesting to have. That's how departments are going to be close in working together. Otherwise, they will never rely on us.
Yeah, and so that actually feeds in well to how I think about a data scientist, right? It's a team. I know one person in my entire career that can do everything, and even he likes working on a team. But I think it's important I approach this in an agile manner, right? So fast, iterative sprints, trying to add value of some sort very quickly. But a team is generally made up of a data engineer, a machine learning expert, an optimization expert, which is about prescription, so how do you do the next best action, or how do you simulate things? And then a data visualization person or a data journalist, because you need to explain this to someone in the context of the business problem, the data, and the model that you're building. And then you just hit on a really important piece, which is in Agile, you have someone that's called a product owner. which is a subject matter expert. And I think it's really important to pull that product owner from the business that you're going to be delivering it to. Because you could build the best model in the world or the best data set in the world. If no one uses it, it has zero value. And so I think it's really important when you do these projects to bring someone in from the business, and I put that in quotes because we're an NGO and government audience here as well. So think about the end user, right? And it's also important to picture these in the context of your consumer of these outputs. And having a team like that with a diversity of skills and backgrounds is really, really important. And so why don't we get into the next question? And then this one's really focused on the pipeline of talent. And you know, how do we build the pipeline of talent effectively? Because this is a rare skill set today, or it's seen as a rare skill set. How do we effectively get the people to do this? And Tom, why don't we start with you on the end there, and we'll just work our way back.
Excellent. The first thing, and the obvious thing perhaps, is that every single organization is competing with you for data science talent. So the pipeline is massively important and is hard. So maybe some examples from the UK side. So I lead the Data Science Campus, which is a new group at the Office for National Statistics. We launched about 18 months ago, really with a remit to support data science across both national statistics, but also other government agencies. We're now a group of about 60, and of that group is probably about a third existing government folks, about a third from academia, from university backgrounds, and about a third from commercial sector backgrounds. So we kind of bring this cross-sectoral group, and we spend a lot of time in recruitment and building up skills and so on. But the really interesting thing, when we first arrived, sort of started talking with the other groups in government, became really clear there were already huge skill sets here. And this kind of, data science is a newish term, but it's not a new thing. We've, it's basically a label for kinds of work that groups have been doing across operational research, across engineering, science and engineering, across IT teams, across even geography teams. Every single team in any agency has people with elements of what we've been talking about today. And so we sat down and we said, how many people are like this in the UK government? And the current estimates that we've got of people who are really self-identifying as data scientists are something like 1,500 people across the group. Now, they vary massively in experience, in background, and in focus. But you've got a lot of mathematicians and a lot of deep engineering expertise, a lot of software and digital expertise. So you've got a lot there. You've also got a lot of domain experts. So I've talked about using satellite imagery for Earth observation, for then producing global statistics and so on. In the UK, we have many teams interested in that area. Similarly, you've got groups looking at, for example, what can we find from mobile phones for commuter patterns, for other movement data and so on. So there's a big group there already. So the pipeline is often about leveraging the skill sets that you have in your organizations. And so for that end, what we did was really set out and say, okay, how can we build and strengthen those teams and build and strengthen the data science talent within the system? So we've launched a number of things. First up, we have an apprenticeship program, and this is bringing in new folks with skills basically around science, technology, engineering background, but in some cases straight from school. Now, this is way back down the line from the sort of PhD with machine learning that people often have as a kind of a feeling of what a data scientist is. But you can be producing value quite quickly through vocational training, through working and embedding in teams that are working on problems that actually data science can help with quite quickly. Moving up a little bit, we run a master's program in data analytics and data science for government, and universities are helping with that and supporting that. And that's a great way of upping your skill sets. And we sponsor folks from across government to go through that master's program. Then moving further up, we have a joint PhD program with the Turing Institute. So this is the National Institute in the UK for data science and artificial intelligence. And again, what we're seeing there is there's a great appetite in other parts, other sectors, so not just government, to work on problems of social good. People in universities want applied projects to work on. If you've got data and an impact that they can then see and apply their skills to, they're desperate to come and work on your challenges and your problems. So that's a great way of building the pipeline in, because the pipeline is not always recruiting and it's not always growing your skills. Often it can be about placements, secondments, people coming in on tours of duty, for example. So I think those kind of three areas, certainly where we see a lot of value, a lot of development, and a lot of strengthening of skill sets within government, within national statistics. So I think they're kind of absolutely fantastic sort of to keep expanding on. And the final one, really kind of to talk about, it very much is the team sports we've talked. You need every element of that. And the aspects of working in teams, the aspects of working with what you might call customers or end users of your analysis, they are fundamental. So it's not just the technical side. So let's not forget that. And I definitely think all programs should build that in for successful data science projects.
Jose?
I think the industry has done a lot for us over the last 5 to 7 years. I remember 8 years ago when the first data science concept was trying to be addressed. And I remember it was always called as a statistician who knows more about computer science than a computer science, and a computer science that knows more about the statistics than the typical computer science. The thing is, there was many people like that 8 years ago. I mean, it's a clear unicorn profile. But since the industry has started to request more and more and more of them, what happened is that I've seen over the last 3-4 years that many universities have started to create these joint together mathematics, computer science degrees. They're starting to pop up everywhere. So I believe over the next 2 to 3 years, these new people, it's going to come out. It's going to start wanting to work on data. And I think the main responsibility, they will come with a background. They will know how to use R. They will know how to use maybe big data technologies. They may know how to do any kind of machine learning algorithm, create visual analytics, they will have that background. They will lack the experience. They will have definitely background. So what is left for the entity, at least for myself, what I think is critical for the companies to teach to these students is responsibility. Responsibility and security. I've seen whenever I hire someone in my team, they come and then realize, hey, I can't install my own applications. No, you're in a production environment now. You need to adapt. We can be flexible, but up to a point, because security is on the way. So they need to understand you can't do anything you want with the data. There is a certain level of responsibility you need to take whenever your data is leaked, whenever data is shared across presentations. They need to understand that. It's one of the main responsibilities of any company. To be flexible, but at the same time, to teach them responsibility and security. Because the background, they have it, and they will pick up the experience along the job. If the data allows them to work on clustering algorithms, they will get experience of clustering algorithms. If your company is working on Python instead of an R, they will get experience on the job on Python rather than R. But the main responsibility for a company is to make them understand that when you're working in the real world, there are certain limitations, and it's always important to be responsible with the data you handle. Otherwise, we might face another Cambridge Analytica situation.
Excellent. Eva?
Yeah, I think my view is really it's a team sport, and you have to split the roles. It's similar like in football. You can't have somebody who's amazing in the tech, in defense, and the best goalkeeper ever. And so it's in data science. If you free up the resources and you make sure that the person who's amazing in coding and understand the algorithm is not responsible for the law side of the business, to make sure is not the person who's responsible for the infrastructure and so on, you actually manage to find the people you're looking for. I like to often compare where we are in data science to where we are or where we were in marketing in the 1920s. And it's something that I actually see in my region a lot is in the 1920s, people realized if I put onto a magazine a sentence saying my soap is the best soap, you end up selling more. And they were like, great, we need that people. And so they hired lots and lots of people, and they were like, this is the bluest soap, this is the pinkest soap, the most sportive, the most luxurious. But they were all over the place, and they had no strategy. And that's why they realized, okay, we need to set up marketing departments, we need to have a marketing strategy, and we need to have a plan, that a team that interacts, that works well, and that supports our corporate strategy. And that's what I see in data science. I sometimes think we're at the point where we think somebody who's really good in PowerPoint is the best person we can find in marketing, because we go and find the person who's really good in coding, and that's our data science team. But that doesn't mean they can talk to the customer. That doesn't mean they understand how the business works. That doesn't mean they understand the product, or to make visualize things in a way that actually people can act on it. And that's why on the internal side, it's really important to split the roles. On the other hand, as IBM, we also we are aware that there is a lot of skills to be developed. That's why we offer, for example, apprenticeships. We work closely together with the universities. I myself, I teach at RIT here in Dubai. And with that, we raise the awareness and we raise the level of skills, and we heavily invest our time and money into building the skill sets in the region.
Okay, Jorge?
Yeah, so in my opinion, I remember in 2012, when I was in Australia, yeah, I made a personal development plan for the company that I was working on. Yeah, and then I noticed, yeah, that in a lot of universities in the United States, yeah, well, I read that someone wrote that in the coming years, yeah, it will be a revolution in terms of people using technologies like R, like Python, yeah, because in the universities, yeah, most of the students, they started to do, yeah, all the data science, yeah, using open source. Yeah. Why? Because they had access to these tools. Before of that, they were really specialized statistics package and statistics software. Yeah. So then I said, wow. So how we should work, yeah, in this company for the next years in terms to produce for them a personal development plan, yeah. And then I started to work with universities, because I think that the universities, yeah, there is a good source to find, yeah, knowledge, because especially in the United States, you know more than me that they invest a lot creating their own software. For example, software like Weka, like other softwares has been created by the university, Berkeley, or other ones. And that's one thing, no? The other thing is in terms of, and I spoke also with one guru, yeah, some years ago in 2011 also, and he told me, Jorge, it's important to invest in technology, but also it's very important to know which algorithms, yeah, are coming. Yeah, so companies, they should, yeah, also spend their money, yeah, not only in training the people for the technology, for the tools, also they should invest the money discovering very good use cases, with algorithms, yeah, are using for these use cases, yeah. And then, and I thought, wow, that's good. And the third part, yeah, it was when I was working for a consulting company, and I was doing one assessment for a company in terms of how they should evolution, yeah, in their data science capability, yeah. And then I thought that identify employees in the companies that they have some background in mathematics, that they have some background in IT, that they have some background in marketing, in the business, and then create a group, yeah, of people that they can work, yeah, with the focus, yeah, on to obtain very good results, yeah, or applying machine learning. Also now we are talking about artificial intelligence, but artificial intelligence, behind the artificial intelligence, we have to consider that there are advanced algorithms, yeah, about that. So when we see a robot, and the robot is doing sentimental analysis, because the robot has algorithms behind that are doing image recognition, and also they are doing sentimental analysis, voice recognition, but not only voice recognition. There is also, they are recognizing by our voice if we are upset, if we are not upset, if we are happy, if we are not happy. Yeah, so there is a huge of things, yeah, that you need to think in terms of how your team needs to evolution, yeah, in the future. No?
Yeah,
so.
and this is actually an area I'm quite passionate about, and I think it's important that we all admit that, you know, we say AI is not going to replace all jobs, and it's not going to replace all jobs, but there are some jobs that are going to be dramatically affected by implementing AI, and I think it's really important for us, and I mean us, everyone in the room, and business leaders and government leaders, to think about how we can help people that would go into these blue-collar jobs to get the skills to operate in these, we call them new-collar jobs in the new world. And we have, you know, we've developed apprenticeships focused primarily on people that don't have college degrees or that have maybe a 2-year degree, to give them the skills to participate in the process. They will never be a data scientist, 90% of them, but they can participate in the process. And you know, connecting it to things like the online courses, those are valuable. Even classroom courses are valuable, but you don't really learn it until you do it. And so it's important that these programs have on-the-job training where they actually participate in programs. And then even thinking about people in our organizations, how do we reskill them? So how do we apply the same type of program to a reskilling program so that you can then do this? And we're developing these programs. They're being certified by various governments as apprenticeships, but more importantly, we're committing them to open source, so that anyone can use them, so that they can be developed and added onto just like other open source projects, even developing university curriculums that we're open sourcing, so that anyone in the community can have access to them in a very portable manner. So this is an area I'm extremely passionate about, and I think is critical to the future, because you know, there's going to be, there is a tremendous need for it today that can't be filled. The future needs are going to be even larger. Tom, you wanted to add something?
Yeah, I just wanted to come in on 2 examples around that learning by doing idea, and concrete examples. And the first is that in the UK, we run, along with another part of government, something called the Data Science Accelerator. And this is a 3-month mentoring program. So any part of government, so any analyst, any researcher, any policymaker and so on can bid into this program and get 3 months support from accredited and trained and experienced data scientists from other parts of government, including my team. And as an example of this, one part, the UK Hydrographic Office, which produces data and charts on the seas and produces the UK charts, etc., asked the question, what could we take from satellite imagery that gives us a faster readout on objects in the sea? So things like wind turbine arrays, oil platforms, and so on. Let's make sure that they're all exposed, that they're all on the charts and so on. So they put in a bid for this program, and one of my team mentored them. And within 3 months, they'd moved from that concept through to a working prototype trained up using UK data, through to a global or international array output, which is then being mainstreamed into production. Now, that 3 months for them was a huge step forward in terms of prototyping a new idea and a new data source. It also helped their team learn up and train about some of the skills that are involved, and critically, it was owned by their team. So it was very important to them to solve that problem. So really, the kind of data science aspect from our side was a capability building. That program runs across government, and it's been very successful. And I'm not sure what to date the numbers, but we're talking about hundreds of projects that have been run through that. So that's a concrete example of really what any organization can look at, and basically sort of leveraging or upscaling the impact of particular data science group individuals or data scientists within your teams. Second example, I mean, going back to the apprenticeship program. So one of the projects at the Data Science Campus is using street level imagery, so photography about streets around the UK and around now internationally, to answer the question about what's the local environment like. We know that things like trees have a huge impact on removing air pollution, on quality of life, well-being, and so on. There are certain attempts to quantify that. In the UK, we think maybe £1 billion per year impact. But what we don't have is spatial data sets at local level on that kind of issue. So if you want to build that factor into your models of health outcomes, for example, you need that data. So what we did was sample Google Street View at 10-meter intervals around the whole road network, something like 20 million images, and start running those through image classification systems. Output of that is a spatial data set that others can use. But what we then brought is our apprentice group in on this to actually upscale that. And so for the UN Global Platform work that we were talking about earlier in the week, one of our apprentices has essentially put that into a container for anyone in the world to run and apply the same tools and techniques on. So in very quick time, that apprentice has come in and started delivering value and impact, both around software development, but also applying some of the techniques and technologies around that we've got available. So I think there are some great concrete examples like this that can perhaps make it a bit more real for people when we're talking about the ideas.
Yeah, excellent. So we have about 20 minutes left, and we have, well, I think there's one question that's critically important is, you know, what do leaders need to know about data science and data scientists particularly? And then if you could also work in any closing remarks you have, and I'll give you each 4 minutes so that we can end on time. And so, Eva, why don't we start with you? So, you know, really, what do leaders need to know, and any closing remarks you have?
I think what most important for me is that leader needs to know about data scientists is that we need to be able to develop our own ideas. I think I've seen the biggest impact of teams when they actually got what they needed to perform, and the freedom and the support. And I'm a big fan of what is called servant leadership. So what I say is my job as a leader is to be there to make sure that my team can work frictionless, and that they can work happy together, and that they have a platform where they can share their ideas. And as a leader, you're there to maybe give a guideline, an idea, and saying, okay, and remind them this is where the goal is, this is where the outcast is, because also juniors are often at risk of what I call chasing the cool. And in chasing the cool, I mean, they look at all the data, they crunch it, and finally they go like, oh, great, Friday morning people wear brown shoes. And you're sitting there like, yeah, but it's a bank. and just being there as a sparring partner, as a support, as maybe the old wise man or woman, and saying, okay, are we still heading in the right direction? I think that is, for me, where I see the leadership. I forgot the second one.
Any closing remarks?
I think overall I'm very optimistic. I think we see a massive increase in skills, in my opinion. We see a big increase of skills around data scientists, around the core. We see a lot of questions on law sides, on ethical topics, on business topics, and I think by working together and building a society where we value the impact that everyone brings, that's where I see the biggest driver. And I also, when I spoke about diversity earlier, I think we always think like, oh, the technology is biased. And no, the technology is actually not biased. The algorithms aren't biased. The data that feeds into it is biased. And it shows us what a biased society we are. And when we build machines that predict for certain kind of jobs for women and certain kind of jobs for men, it only predicts it because that's how it was trained. And so you can judge the technology and say the technology is wrong, or you can say, oh, actually, this is where we have to change society. And with that, we open up a massive spectrum of self-reflection and of opportunities for our world.
Great. Jorge?
Yeah.
And Jorge's not checking his email, he's taking notes.
Yes. No, I'm taking notes because I am, as I said, I'm a statistician, and my memory is very, very bad. So I need always to rationalize and write notes. Yeah. So the first thing is about, I think that, and this is a conversation that I have a lot of times at the C level, that is trying to identify what is the analytics maturity level in the organization. Yeah. So, and I think that analytics needs to start, yeah, from the top, and the C-level, they need to understand what are the benefits, yeah, of analytics, of artificial intelligence, and of from the data scientists, people working in the organization. I think this is crucial. Yeah. So sometimes I found when I have when I meet, yeah, with the CEO, yeah, with the CFO, yeah, with the CMO, yeah, I found, yeah, that is a lot of times there is a lack of analytics culture in the organization, and that's key. And this is something that we have to push, yeah, and we need to collaborate, yeah, with the leaders, not only in the organizations, also in government, because also I work for government institutions, and we need to provide not only to the C-level, but to the complete organization. There are companies like, for example, Telefónica Spain, that they are producing training in big data to the whole organization. This is one example. The other things is that I love about this digital world where we are is that now things have changed. We love share information. We like to share information. So now the people, the communities, they share code, they share algorithms, they share knowledge. Yeah, we are a community that we are very accessible ones with another one. So that's my message. No, my message is, and I think as you said, that the world, yeah, is changed. Also, is more collaborative. Yeah, and we are going to do things faster, yeah, and with bigger impact. You know, that's my view.
Great, Jose.
I think I'm gonna be a little bit blunt here. I mean, I'll probably kick out at some time. Somebody will kick me. It's not about what leaders needs to know. It's about leadership needs to evolve. Why? Because I just remember 6 months ago when the entire Congress did an interview to the Facebook CEO, and the questions were like, when I was looking at this, these guys has really no clue. They don't know what this means. They don't know what you can do with the data. And it's very important for the leaders to either they really get a background on what can we do with data, or leaders that had that background, so, or people who had that background become leaders in the future. Because money aside, it's exciting to be a data scientist. There is no better feeling than going home. It's like, hey, I just created a new algorithm because I had it in the past. Like, who can predict how much is going to be the expenditure of a client of the bank, so we can predict it for the next month. If there is any weird thing, we can tell this guy. So this guy can be noticed just before something fraudulent happened to him. It's amazing. It's an amazing feeling, and there is nothing better. But then the problem is business comes in, and money. Money is the only thing that matters to us. Then it's the sensitive subject, because that same algorithm that was very exciting to me to create, because I wanted to help people, it can be transformed very easily into something potentially dangerous to people. So it's extremely important for leaders to know what can you do with data and what you cannot do with data in terms of security, in terms of regulation, because even if you restrict a little bit the limits, there's still a lot of things that we can do. There are so many things. People ask me, why you can't give me the data of customers? I can't give you the data of customers because it's customer level information, and obviously it's extremely secure. But I can work with you and creating something amazing for the customers. You can gain money, you can make money. I'll give you an aggregation of the data. I'll make sure the regulation is clear on what I can give you and what I cannot. To me, this is the most important thing, because right now the regulations are either too restrictive or too loose. There is difficulty for the leaders to find that middle ground that will make data science boom with, at the same time, protecting the citizens. It's very, very, very critical. Another point that you mentioned before, about a little bit about the future, is leaders need to understand that from a data science and AI perspective, they need to change the way people is educated. There is a lot of potential of people losing jobs in the future due to AI. Yes, true. because we need to change the way we educate people. It's no longer about knowledge. It's more about curiosity. It's more about how to think by yourself, have creative thinking. Because creative thinking can never be replicated. I don't think, at least on the next 200 years, it will be replicated by an AI. So new jobs will come up. I'm a Kickstarter lover. To me, it was one of the best startup ever created. It's people who bring their ideas to the world, and people pay for them, and they basically support all these startups to be created. And it could be the same for data, and it could be the same for AI. It's just helping more and more people to have creative thinking. Because it's no longer going to be, I'm going to check the size of one screw in one machine. Because that is the job that will be replaced in the future. And in terms of data, it's like I said, it's very important to them to understand the real potential. And without a really good background, it will be challenging. I know that it will be challenging for many leaders, because if they become too loose, potential dangerous things might happen. And if they become too restricted, they will just block they will block the future at some point.
Excellent. Tom?
Excellent. I think the 3 areas for leaders are always ownership first. You've got to own this as a leader, but also as an organization. So you don't ask questions like, what does data science do? What can data scientists do for us? Because that's this concept of someone else coming and helping you. You've got to own it. You've got to say, how do we use data science along with all of the other tools we have to fundamentally improve as an organization what we're trying to do and fundamentally tackle the big challenges. So that's the first thing, is around ownership. And I think that's the same for every single technology transformation. So if you look at, say, IT and digital transformation, it fails when it's seen as something that the IT department does over there. You have to own that as a leadership team and as a leader and say, how do we use IT? How is IT fundamentally part of our organization and our work? So that's the first thing, ownership. The second thing is around people, and we talked a lot about skills. And data science is everywhere in your organization already. You may not know it yet. So I have conversations regularly with statisticians who say, data science is just statistics, and we've unpicked that a little bit today. You know, it's just a new label. Then I go into the next meeting, and I meet 100 operational researchers who say, well, data science is just operations research. Same thing. And then I go to the next meeting, and I meet scientists and engineers and say, data science is just science and engineering approach. All of those are true, and you've got skills like that in your organization already. So it's about people and uncovering those skills and making sure that you're supporting them. And the third area, I'd say, is around infrastructure. And we think a lot around digital transformation, around giving our teams the kit, the IT, the support, and so on that they need. I think here the point is data transformation. You need to see this as a fundamental part of your organization, your business model, if you use those phrases, or the way that you provide value, impact for society. So data transformation there is very much around, how do we own this? Do we have the skills? Do we have the infrastructure and the technology in place? So those are the kind of 3 areas I'd say for leadership. And that's the same for every single area of technology transformation, of progress and so on. So very much, you know, part and parcel of that. Final one, and we make closing words. I think we're just getting started, obviously. I think there is a huge interest around this area. For me, the big difference is the technology and techniques are not the difference. They're not the differentiator. We've got some new tools in the kit. That's great. We've got a lot of new people involved. That's brilliant. But what's really changed is the recognition across the landscape of what value you can produce from data and from the tools and so on that are available. So that higher level understanding, if you're interested in policy making or you're interested in your business transformation or your changes or delivering to customers, you get those analysts and those data scientists in the room now. Previously, they would be in the back room, as we've kind of just heard. So that's my final maybe closing thought. We're just getting started. Keep pushing onwards, because there's a lot more to come. And I think across all of our organizations and areas, there's just a huge value that we can provide here. So look forward to working with you all.
So I think there's a couple of important pieces for leaders to know, in my opinion. One is that organizations that leverage AI are going to supplant those that don't. Whether you're an NGO, a government, or the private sector, if you use AI, you're going to outperform whoever is around you. The second piece is related to that, which is AI is not going to replace leaders. Leaders who use AI and data science are going to replace those who don't. And I think that's really important to know. And then I think there's another component that we hit on, and that is really as leaders that are leading this space, or that are leading in data, which everyone in the room is, I think it's really important to understand the risk associated with bias. Don't be scared of the bias, because as you get data in, your model is going to be biased. It's really understanding the bias, understanding what's acceptable bias and what isn't acceptable bias, and then working to fix it. And I think that is critical, because as you go through this process, you're not going to know if your data is truly biased until you start building your models, till you start seeing the output. But having an end state in mind and knowing what good enough is so that you can put that into production, whatever that means for you, and then continue to improve it is really, really important. And so I think that is absolutely critical. And the second piece is around talent. And we talked about this as well. You know, it's really important to have a diversity of talent in this space, because it brings a diversity of perspective. And it also brings it helps eliminate or reduce, I shouldn't say eliminate, but reduce some of that bias, because you have people from different backgrounds, different genders, different ethnicities, different economic backgrounds that are conceiving and thinking of these models and looking at the output. And from their eyes, they're going to see things differently than maybe I would. And so it's really important that we have diversity of thought, I'll call it, in these teams, so that we can move them forward in the right direction, in a fair and balanced direction. Most voices are heard, and that is critical to the success of this field in the future. And then just to kind of summarize what we talked about, you know, I think you know, teams. You heard a lot about teams today through all the questions. Teams are absolutely important for the success. Getting involvement from the end user is really important. And I think those are the two highlights from what we talked about. And then just in closing for the panel, thank you all for participating. I'm very honored to be on stage up here talking with you. And equally as important, thank you to the organizers of the event and the UAE for inviting us all to speak and share our thoughts and views on these subjects. So thank you.
Thank you.
Thank you.
Thank you very much.